Hello, and welcome to Two Dancing Clams. The following is a Blender 3.4 tutorial showing how to accomplish this effect. Yeah, love that. There is a very useful technique in Blender to apply a texture to a spotlight and use that to create an environmental lighting effect. This is not that. This technique was developed because, first and foremost, I want an effect to cover all the surfaces continuously, not just the surfaces hit by one spotlight. I also wanted greater control over the color than I was able to achieve with the spotlight approach. This is what I'm calling fast, flexible, fake caustics. The project file for this is available on Gumroad. Check the link in the description. Also, I frequently get a comment that people can't read the geometry nodes. It's usually because YouTube defaults to a lesser resolution. To fix this, go into the YouTube settings and change it from automatic to 1080p, and you'll be able to see a lot better. This gives you some idea of where we're heading. So there is a sphere in the middle of the scene that you cannot see because it's been marked invisible for reasons we'll get to in a while. What we do is raycast outwards from this sphere in every direction. The sphere also has a texture applied to it. When we get a ray hit, either on an object in the scene or on a wall, we create a little object immediately adjacent and parallel to the point we hit, and that object will be emissive, and it will get an amount of light producing power based on the Musgrave texture where that ray initiated, and an intensity also based on the same thing. There's a million details in here, but this is where we're headed. Let's get the world set up. First of all, I'm going to use Node Wrangler, so go to Edit, Preferences, Add-ons, Node Wrangler, and make sure it's enabled. It is. What I'm about to do only works in cycles. Go to Render Properties, select Cycles, and for my own self, I'm going to turn on GPU to speed things up. For the rendering, I know I'm only going to want 128 samples when we get this far. Going down to Output Properties, I'm going to want to start the frames at 0, and 160 will be enough. This way we don't have to come back here and fiddle around when we're ready to do the rendering. Now I need some objects in an environment for these lighting effects to show up. So I'll create this first. Open the Geometry Node Editor. I'm going to call this Room Objects. I'm going to want a shadow box to display this in. So let's create that now. Don't want the default cube. So I'll create a box about the size of a standard display and press numpad 1 to focus it on the front of it. I want to delete one face so that we can see into it. And we'll just delete faces until we hit the one we want. And face 1 is the one that's facing the camera, so let's get rid of that so we can see into our box when we have no use for this light. I want to create some objects for the light to play with inside this box. And this time I'm going to make them random. So I'm going to use an instance on points. 4 should be plenty. I want them inside the box toward the back. If they're toward the front, then the lighting effect will be away from the camera and wasted. So this gives me the spread I want for that. It's minus 20, 10, minus 10 for the minimum, and 20, 10, 10 for the maximum. When these objects get created, they need to be realized or they won't interact with the light sources. Now I could just do cubes, but that's a little boring. So what I'm going to do is I'm going to create my own instance collection. Let's give this a bit more size. Now it'd be boring if we just instanced cubes, so let's give it some spheres too. let's look for a pleasing distribution of objects. Yeah, I like that. This is not a huge trick, but it is kind of cool that if you want a collection of objects, you can create it yourself. I mean, this could come in from the outside as well, but I like creating things inside geometry nodes. And you could have any number of these. The advantage of this is all of the objects are controlled with a single point cloud. Also, all the objects are scaled by the same amount. Now let's get into the good stuff, the lighting. I need another set of geometry objects. We're doing this because the light emitting objects we're going to create can't be visible in the scene and can't cast a shadow in the scene. However, something to keep in mind is these objects we're creating could be made invisible to the camera, but could cast a shadow and not emit light. So if you want a shadowy effect traveling across the environment rather than a light emitting geometry crossing the scene, that's possible too. Start by creating a new object in the world. It doesn't matter what it is. Might as well be a plane. And I'm going to call this light mask. Add some geometry nodes to it. A dot so we can see the nodes we just created. We won't need the plane, but we will want a sphere. So start off with an icosphere, 2 meters, 6 subdivisions, and I'm going to goose this a little bit more with another subdivide. And that appears in the middle of our scene. That's what's going to eventually turn into the lighting effect. One of the things that's going to help us do that is the Musgrave texture. Now usually when you use a Musgrave, we would use it inside a shader editor to change the color of an object, or in the geometry nodes editor to change the shape of an object. In this case, we're kind of going to do both. We're going to use the Musgrave to delete some of the geometry in the geometry nodes, and we're going to use the Musgrave to determine the color of the light in the shader editor, as well as the intensity of the light in the shader editor. And I want these all to be drawings from the same data, so I'll create it here. And save it so that everybody can get it. Now would be an excellent time to actually create that texture. Material properties, give ourselves a new texture. Could give this, call it material emission, and set the material. Now let's go into the shader editor and make this look like something. So we want access to the data that we created in the geometry nodes. That's easily done with an attribute node. There we go. Now it turns out that the shading on the ball itself doesn't matter. What we really care about is the emission and the strength. But it's nice to be able to see something just for now. Black and white is fine, but I want some color for this. Let's jazz it up a little bit. I'm going to start with a dark blue. And add a red. A little bit brighter. And a yellow. Brighter still. And give us a little white at the end. And I'm going to have these colors go constant, so it'll snap from one to the next. I think it, especially when you're dealing with emitter, subtlety is not really what we're after. And the other thing I noticed from playing with a spreadsheet over in geometry nodes was Musgrave textures tend to run from minus 0.9 to positive 0.9. The color ramp is expecting a number between 0 and 1. So let's adjust the range a little bit to make that work better. By the way, it is really handy when you want to know what's going on with colors in the shader editor to look at the data in geometry nodes, because there you can bring up the spreadsheet and examine the data directly, as opposed to the shader editor where you only have visual effects to try to guess what's going on. It's much less precise, and I don't like it. And this will be what we use for emission 2. That looks pretty good, bearing in mind that a lot of this blue is going to be deleted. I think the color balance is about right. Now we want to control the emission strength. I want the white to be pretty bright and the blue to be pretty dim. So we could just hook up the factor to the emission strength. But I wanted an effect that was more intense than this. So I'm going to actually run this through a power function. Power. and we'll give that 0.167. Basically what this does is provide a sharp ramp up at the end, so the whites are even more intense. Let's go back to the geometry nodes. Now one of the things I know I'm going to want later is the normal that faces outward from the sphere. So I'm going to go ahead and save that into the geometry also. In most cases, you can do a capture attribute to accomplish the same as this. It just gets a little bit uglier as noodles crisscross your stuff. And there are some things you can only do with stored attribute, so I just think it's the better go-to. Now the deal is, if this emitter is stuck in the middle of our scene, the light will be diffused and mixed together by the time it travels a very short distance. So what we want to do is move the points from this sphere to very close to where we want the light. And we're going to do that with array casting. Now the target geometry for this ray casting is going to be these room objects. So we can just drag them over. And the direction of travel is going to be from the center of the sphere outwards. And we conveniently save this normal for that purpose. Except it's going to work a lot better if it's actually a vector. Oopsie. And if we use this to do a quick supposition, I can show you what we're heading towards. And that's kind of it. So you can see the ray just kind of blasting out and touching every surface. Now one thing we want to do is delete every point that doesn't hit a surface when it's raycast. And so it will be the opposite of is hit. So not is hit. Now this looks a little crazy because the new surfaces are actually commingling with the room objects. We don't want that. We want the light to be close, but not exactly on. So we can get that by using the hit distance. I'm going to use 0.98 for this value. So instead of having these points travel all the way out along the ray, I'm just going to have them travel most of the way out along the ray. So we can do that is we can take this direction and use a vector multiply by this distance and use this value to control. And make note I'm plugging it into the offset here, not the position. It's the offset from the old edge of the sphere, not the center of the sphere. And the other thing we want to do is in the lowest values of the Musgrave, we actually want to delete the data. We want to have holes in it. So I'm going to add another condition to OR this with. So if the Musgrave value is less than, let's say, 0.1, we will also delete it. We can get an effect here that's a little bit more scattered, but I'm not entirely pleased with that. Let's go back. A scale of 3.2 and a detail of 1.4. On the spheres, you get kind of a weird lighting effect. That's because some of the vertices are hitting the sphere and some of them are going past the sphere and hitting the wall, which leads to some really long polygons in between. In order to get rid of that effect, instead of using the original sphere geometry to emit light, I'm going to use those points and create little light emitters for each point. That will prevent this tearing problem. I want these little flat emitters to be parallel to the surface that the raycast hit. And that is exactly the hit normal, so let's save that. Now to create these emitters, I'm just going to do an instance on points. And I want little flat hexagons. And we need these filled. And I think a radius of 0.45. Now we can make use of that normal we just made. Yeah, that's exactly what we want. So there are some good explanations for align Euler on YouTube videos, but very briefly, what we're asking it to do is all of these mesh circles were created on the xy plane with the z pointed upwards. And what we're asking align Euler to tell us is what will it take to get that z value to align to the surface normal and give us that rotation. And then we plug that rotation into our instance on points, and suddenly all of our little flat emitter thingies are parallel to the surface. Now, in order for these objects to interact with light, they need to be realized. So in order to make the lighting effect better, I found that a merge by distance to merge some of these little emitters into bigger emitters works pretty well. Use a value of 0.381. And you can see what it did was it basically consolidated some of these instances into single objects. Now, there are a lot of refinements we can make to this. We could have the amount of merging be done relative to the distance from the source. As things travel, they spread out, so we want to merge over a greater distance. We could have the size of these objects get bigger as they go farther from the source. There is just some point I have to say, this is enough complexity for now. Feel free to revisit this if you want to refine the effect even further. And the set material was done on geometry that's pre-instance on points, so let's set that again. And that is a large part of the effect we want. One of the reasons we kept this light mask separate was it needs to be transparent and it cannot cast a shadow. So if we go to Object Properties, scrolling down to Visibility, we turn off Camera, and we turn off Shadow. Now that is much more like the effect we want. Now the only thing that remains to be done is to animate this. We can do that by rotating this sphere that we created up here. We're going to use a vector rotate in a set position to accomplish this. What we'll be rotating is the position of each point in the sphere. I like an axis of 111. Now this angle, we essentially just want to provide 0 through 360 degrees, or 0 to 2 pi radians, or 0 to 1 tau radians, whatever. So we'll start with the seam time. That gives us a frame number. Divide the frame number by 160. You might remember we set the total number of frames to 160 right back at the beginning. And we need to scale this up for radians. And to accomplish that, we multiply by 2 pi or tau. Let's set the camera for a good view. I want kind of a face-on thing so we can see this happening. Select the camera, and then select the camera. Options. We will need a bigger clip distance. Let's go for 500 just to play it safe. I'm going to press 1 on the numpad to center the view, N to pop out this menu and go to View, and we will lock the camera. Control-Alt-0 to set our current view as the camera. Now we can pan and zoom and set ourselves up for a nice front view. Now usually I'd render to PNGs, but I think for the sake of expediency, I'll just go ahead and render directly to a movie this time. Go over to the output properties. Going to change this to FFmpeg, and I'm going to keep the defaults. I'm not a graphics artist by trade, so most of my stuff is heading toward YouTube or a D&D campaign, so the defaults are just fine with me. And then Control F12 to render. Or not. See? I always forget something. The default number of samples is crazy. 128 will be fine for the same effect and will also greatly speed up the process. And sometime later we have this. Control F11 to see the result. I think that's glorious. I really like this. And the idea that I can finish a scene and then put a light show across it and have it touch every surface is just amazing to me. If you want to see more about what can be done with imaginative light effects, there's a video linked on the left right now. I hope you enjoyed this. Thank you so much for watching.